there, this is the walkthrough video for Tuesday. It's April 8th in Try 3 Week 7. Today's the 1 year anniversary of the total solar eclipse, actually, which is exciting. I'm glad that we had sunny skies and not the gray ones that are coming in tomorrow. Hey, these are some animals in an evolutionary tree. There are all kinds of things that we can draw these relatedness trees for, but you can tell that they share a common ancestor because they all come off the same branch. This species here was the last common ancestor, and then as things moved kind of upward, you see that difference. So you can tell that animals in an evolutionary tree share a common ancestor because they all branch off the same part of the tree. Today, we're going to analyze diagrams that for your purposes are the same. Phylogenetic trees and cladograms. For the non-specialist, those mean the same thing. And we are going to analyze related situations because these diagrams show us relatedness. I think I'm so funny. So it turns out in class, there was not time for missing or late work. I have gone through as of today and made all of the things that you can't still turn in are no longer missing. So that should help as you are being polled next week for or choosing to sign up for Panther Plus. Just a reminder, if I sign you up for my Panther Plus or the robot does, you do need to come, even if you are up to date between now and then and you do have some things you need to do. So hey, let's take a look at our table of contents page. It's one new entry today. It's called tree thinking, and we are indeed going to turn it in. All right. So we have thought, as you are aware, about changes within one species based on the environment, whether that is changes in rain, whether that is changes in the environment, whether that is changes that humans are making within one species, or that human actions are causing differential natural selection survival so that some in the population are better able to survive and reproduce. That's an adaptation, the physical trait they have, and they can spread it throughout the population. But all of these stories, excuse me, are examples of change within one species. So this picture I keep showing you is actually of 4 different species. And the question is, like, where do 4 different species come from? Like, how can you analyze that data? So today we have to learn about tree thinking. But before we do that, one thing that's really hard for people to wrap their head around is the amount of time that the Earth has had for change to happen. So you should go check out slide 226. I don't know what it looks like for you, but it's here as I'm making your canvas for today. This video is by National Public Radio. They are at a university campus, and they are going to use the football field as a timeline of Earth's history. And I think it just goes to show you that we look at this big diversity around us, and it turns out that that big diversity has had a lot of time to develop. This is a tree of life, all coming from the last universal common ancestor. Each of these lines represents a separate species. Sometimes you'll see they branch out. Sometimes it's hard to see these are the dinosaurs. You'll see they go early. But that tree is the very same type of tree that Darwin drew in his notebook in the 1850s. Boy, you think I would know this by now. It's definitely the 1800s. And this isn't a picture of a real life living organism. He wrote, I think. And he drew this in his notebook to think about where diversity had come from. And from that, we do a lot of different thinking about that. So my friends and I wrote the assignment you're going to take today. It was published in the American Biology Teacher a couple of years ago, back when my kids were very, very small. And you're going to look at 3 trees. You're going to look at this one. This is going to assume that you here have a family where everybody is related to everybody else from ancestors to descendants. That is not true in my family. Family comes in all shapes and sizes. But just a heads up for you, as you're doing this assignment, you have 2 cousins and a sister. And indeed, everybody is related through gametes and fertilization. So cool. The second picture you're going to look at is some languages. We actually think, we made this, and we actually think that Romanian is actually much closer to French than we thought it was. But you're going to use this diagram. You'll see that now we have time along the axis, and that's going to get you ready for thinking about a real life tree. It says here, molecular and radioactive dating of fossils are used to determine the phylogeny of organisms. That's the relatedness. Turtles are organisms with a long evolutionary history. These are all modern turtles. And it turns out we can trace those modern turtles. The fossils look strange because we forget that turtles can like pull their necks in. But when the shells flatten, they often lie flat in the sediment, which means that we can get some really clean fossils out of the layers of that. So you'll also notice that the time scale is a bit wonky. This is 2.5 MYA or million years ago, but 65 minus 2.5 is like 62.5 million years. So it's trying to show you this idea that like we're building this tree so you can see really clearly and not paying such careful attention to the timing. Cladograms are trees because they show relationships. Phylogenetic trees are the ones that show age, but you don't need to know that. I just wanted to show you that there are lots of ways that the trees can take shape. This one is like a, what do you call it, like a triangular branching one, I guess. All of these are related to each other. That's the thing about evolution. The thing about evolution is that we're talking about natural selection in particular, is that we're talking about all those things. We're not, I said evolution, but that was incorrect, right? Because you know that like small population sizes and non-random mating, those also contribute to change over time. The closest of relation is not about what letter they are in order, as you learned from this assignment, right? Like French and Spanish are next to each other, but if you look at the branching pattern, Spanish and Italian are more closely related. The closest of relation is directly related to how recently the two things shared a common ancestor. By the way, these are all, you know how we're Homo sapiens? These are all the first word in that of turtles, but you can pretend that each of these is a species. These are all genuses, but you can say species. Okay, so when we look at trees like this, I just wanted to tell you there's one important thing we didn't talk about. So can you imagine those like mobiles that hang in baby's crib? I want you to imagine picking this up and spinning it and lying it flat again. All of these are the same tree. So look, here's that tree, ABC. I can spin this branch and I can get BAC. I can spin this whole thing and I can get CAB. I can take that and I can string it here too, and you can get CBA. All of these are the same tree. So you can't read across the tips of the branches. You're going to have to look at the branching pattern to figure that out. By the way, who's more closely related here? Reptiles and birds or rodents and primates? They're equally related. It's a trick question. They are equally related because they share the common ancestor most recently for both of these. And there's no indication about time here. All right, that's it for me. I hope you're doing well out there. See you soon. Take care.